Light Sports Aircraft Engine. Light Sport Aircraft Engines. Engine General Requirements. In the world of light sport aircraft, everything, even the engine, has to be lightweight yet powerful. These aircraft have some strict requirements they need to meet, so let's dive into what makes them tick. First things first, a light sport aircraft needs to fit a certain profile. Think of a maximum takeoff weight of around 320 pounds for those not splashing down on water, or slightly more for those amphibious models, a whopping 30 pounds. Speed-wise, they don't go wild either. Their top speed in level flight sits at around 120 knots. And when it comes to stalls, they keep it steady at a maximum of 45 knots. You won't find more than 2 seats, including the pilots, in these aircraft. They're typically powered by a single reciprocating engine and come with some specific gear setups depending on their operation, be it on land, water, or as gliders. But here's the kicker. The engine's weight is a big deal. As the engine's weight decreases, these aircraft can carry more stuff and perform better. I mean, every pound counts. So they've been working hard to make these engines lighter without sacrificing power, using better design, materials, and operation cycles. Now, reliability is key. These engines need to perform consistently, no matter the weather or how the plane's angled mid-flight. The manufacturers make sure they're top-notch through design, research, and testing. While many aren't officially certified by the FAA, they keep tight control over manufacturing and testing, often meeting ASTM standards. But there are some FAA-certified engines out there, and they've got their own specific maintenance standards to follow. These engines also have a timeline to stick to, a specific interval between overhauls set by the manufacturer. This time between overhauls varies based on how the engine's used, temperatures it faces, and the care it receives. Once they hit that limit, it's overhaul time, sometimes even shipping off to an authorized manufacturer's facility. Oh, and don't overlook the engine's size and shape. They vary from single to multi-cylinder engines, and how they're mounted matters a lot. It's all about maintaining the pilot's view, keeping that center of gravity in check, and reducing the aircraft's drag. So choosing the right engine for a light sport aircraft? It's not just about power, it's about finding that perfect balance between weight, performance, and fit within the aircraft. Personnel authorized to perform inspection and maintenance on light sport engines. When it comes to maintaining light sport aircraft, there are some specific certifications and qualifications needed to ensure everything's up to snuff. Holders of a Powerplant certificate have the green light to perform maintenance and inspections on these engines, while Sport Pilot certificate holders can carry out preventive maintenance on their own aircraft, as long as it has a special airworthiness certificate in the light sport category. Now, repairman certificates for light sport aircraft have some eligibility criteria. First off, you've got to be at least 18 years old, fluent in English, and show the skills to determine if a light sport aircraft is good to go for safe operation. Citizenship matters too. You've got to be either a U.S. citizen or someone with lawful permanent residency. But let's talk specifics. To nab a repairman certificate with an inspection rating, you've got to meet those requirements and complete a 16-hour training course on inspecting a particular class of experimental light sport aircraft. Now, if you're aiming for a repairman certificate with a maintenance rating, it's a bit more detailed. Along with the above prerequisites, you'll need to finish an FAA-approved training course that lasts a specific number of hours based on the class of aircraft you're looking to work on, whether it's an airplane, a weight shift control aircraft, a powered parachute, or others. These certified repairmen have certain privileges too. Those with an inspection rating can conduct the annual condition inspection on their own aircraft that's been issued an experimental certificate for operating a light sport aircraft, provided it's in the same class they're trained for. On the other hand, repairmen with a maintenance rating can approve and return to service an aircraft that's been issued a special airworthiness certificate in the light sport category, post the necessary maintenance, preventive actions, or alterations. But hold up, these folks can only perform maintenance, preventive maintenance, or alterations on an aircraft class they've received training for. And if they plan on tackling major repairs, additional training acceptable to the FAA is required. Plus, before giving the green signal for a major repair, they have to show their capability either by previously completing the task satisfactorily or by working under the direct supervision of someone experienced in that specific operation. It's all about ensuring that these certified repairmen understand the manufacturer's instructions and the maintenance manuals before they get their hands dirty and give the all-clear for these light sport aircraft to soar the skies safely. When it comes to maintaining aircraft engines, following regulatory guidelines is crucial. Maintenance providers must have the necessary tools, training, and experience to handle specific tasks. They should possess the knowledge and skills obtained through authorized training, previous experience, and guidance from the manufacturer. Creating a suitable work environment, using proper tools, and employing sound maintenance practices are also key components of the process. In the realm of light sport and experimental aircraft engines, there are various classifications based on operating cycles, cylinder arrangements, and cooling methods. For instance, inline engines with 2 cylinders in a 2-cycle arrangement are available in different horsepower ranges and cooling configurations. These engines might be air-cooled, liquid-cooled, or a blend of both, with a single crankshaft directly driving the propeller or reduction gear. Take, for example, the Rotax engines. The Rotax 447UL and Rotax 503UL feature an inline 2-cylinder arrangement that offers improved streamlining with air-cooled cylinder heads and cylinders. These 2-stroke cycle engines require a fuel-oil mixture or have an oil injection system to ensure lubrication. They're equipped with breakerless magneto-capacitor discharge ignition systems and carburetors, with one pneumatic-driven fuel pump supplying fuel to the carburetors. The exhaust systems direct gases overboard, and these engines come with an integrated AC generator as an optional extra. Moving on to the Rotax 582UL DCDI, it's a 2-stroke 2-cylinder inline engine with liquid-cooled cylinder heads and cylinders. This engine uses either a fuel-oil mixture or oil injection for lubrication, employs a dual ignition system, and features piston-type carburetors and a pneumatic fuel pump. Its cooling system involves liquid-cooled cylinders and heads with a 2-circuit arrangement using an integrated pump to circulate the cooling liquid to the radiator. For the Rotax 447UL SCDI and Rotax 503UL DCDI engines, cooling can occur through either free air or fan cooling. Free air cooling relies on the airstream generated by the aircraft's speed and propeller, while fan cooling utilizes an airstream driven by a fan linked to the crankshaft via a V-belt. On the other hand, the Rotax 582UL DCDI engine implements liquid-cooled cylinders and cylinder heads, with a cooling system comprising 2 circuits. The cooling liquid is pumped through the cylinders and heads to the radiator. An expansion tank with a pressure cap and an overflow bottle helps manage excess pressure and maintain the cooling system's efficiency. Understanding these engine systems and configurations is crucial for proper maintenance, ensuring the safety and reliability of these light sport and experimental aircraft. Oil injection lubrication of Rotax 503UL DCDE, 582UL DCDI, and 582UL DCDI. Maintaining and understanding the specifics of smaller 2-cycle engines is vital for their optimal functioning. These engines are typically designed to operate on a gasoline and 2% oil mixture, which is pre-blended in the fuel tank. The planned oil-to-gasoline ratio for these engines is 150. However, some engines utilize oil injection systems driven by the engine's crankshaft via a pump gear. This system ensures the engine receives the precise amount of fresh oil needed for lubrication. The oil pump, typically a piston-type pump with a metering system, delivers 2-stroke oil to the engine through diffuser jets in the intake. The quantity of oil is determined by the engine's RPM and the position of the oil pump lever connected to the throttle cable. The oil supply to the pump originates from an oil tank through gravity. It's essential to note that engines utilizing oil injection systems are fed with pure gasoline in their carburetors, devoid of any oil-gasoline mixture. Regularly checking the oil quantity in the oil tank before engine operation is necessary, since oil is consumed during engine runtime and needs replenishment. Moving on to the electrical system, engines like the Rotax 503UL DCDI and 582UL DCDI are equipped with a maintenance-free breakerless single-capacitor discharge ignition unit integrated with a generator. Similarly, the 447UL SCDI engine features a similar ignition unit that doesn't require external power and is also maintenance-free. These systems use charging coils on the generator stator to power the ignition circuits with energy stored in the ignition capacitor, allowing for a high-voltage ignition spark. Regarding the fuel system, using aviation gas, avgas, with higher lead content, can lead to increased wear and deposits in the combustion chamber. Thus, it's recommended to resort to avgas only if issues like vapor lock occur or if other fuel types aren't available. Additionally, selecting fuel suitable for prevailing climatic conditions is crucial. For instance, using winter fuel for summer operations. For the fuel and oil mixing process, a clean, approved container of known volume is utilized. First, a small amount of fuel is added to predilute the oil. Then, the required amount of two-stroke oil, adhering to specific standards and a 150 mixing ratio, is added to the container. Gentle agitation helps in diluting the oil with gasoline. Finally, the mixture is transferred to the fuel tank using a funnel equipped with a fine mesh screen to prevent the entry of water and foreign particles. An important safety note: to prevent electrostatic charging during refueling, it's recommended to use only metal containers and to ground the aircraft in accordance with grounding specifications. Opposed light sport, experimental, and certified engines. The Rotax 912, 914 engines are prevalent choices for light sport and experimental aircraft due to their robust performance and compatibility. These engines are horizontally opposed, four-cylinder, four-stroke power plants. Their design features two banks of cylinders facing each other, linked to a single crankshaft at the engine's center. This configuration balances weight and horsepower while minimizing vibrations, making them ideal for installation on aircraft wings, particularly in twin-engine setups. The cooling system of the Rotax 914 relies on liquid cooling for the cylinder heads and ram air cooling for the cylinders themselves. A water pump powered by the camshaft propels coolant from the radiator to the cylinder heads. The system includes an expansion tank that manages coolant expansion and contraction as temperatures change. An excess pressure valve and a return valve ensure proper coolant flow between the expansion tank and the transparent overflow bottle. Temperature probes installed in the cylinder heads monitor coolant temperatures, crucial for managing engine heat. Fuel flow within the Rotax 914 engine begins from the tank through a coarse filter water trap and is then driven by two electric fuel pumps connected in series. The fuel pressure control system ensures consistent pressure, crucial for the proper operation of the carburetors. Any excess fuel flows back to the tank through a return line, and it's essential to regularly inspect this line to prevent constriction or obstructions. The lubrication system in the Rotax 914 uses a dry, sump-forced setup, where a main oil pump, along with an additional suction pump, draws oil from the tank via an oil cooler and filter to lubricate various engine parts. The surplus oil from lubrication points and the turbocharger is directed back to the oil tank, ensuring an efficient oil circuit. An oil temperature sensor in the oil pump flange helps monitor the oil inlet temperature, crucial for maintaining optimal engine conditions. These engines offer a balance of power, reliability, and ease of maintenance, making them sought-after options despite being more expensive than non-certified engines and not ASTM approved. Their design considerations, like the opposed cylinder arrangement and efficient cooling and lubrication systems, contribute to their popularity among aircraft enthusiasts and builders. Electric system: Jabiru Light Sport engines. All right, everyone, let's talk about these fascinating aircraft engines. I'm going to guide you through some exciting details about various engines, so let's dive in. First up, we've got Jabiru engines. These powerhouses are all about advanced manufacturing, keeping the costs low and maintenance straightforward. Imagine this: the crankshaft comes with a removable propeller flange. Why's that cool? Well, it makes replacing the front crankshaft seal a breeze and allows for a propeller shaft extension for specific needs. Jabiru engines are manufactured, assembled, and run on a dyno. That means they're put through their paces, tested and calibrated before they even reach your aircraft. The engine components are machined from solid materials except for the sump, which is a casting. The cylinders? They're machined from tough steel, and guess what? The pistons run directly in these steel bores. Plus, the camshaft is made from the same steel with precision ground journals. The propeller here is directly crankshaft-driven. No need for a reduction gearbox, keeping things lightweight. Now let's talk about the ignition system. It's all electronic, no hassle with timing adjustments, it's fixed timing. And hey, it's got backup, fully redundant and self-generating, not relying on battery power. This engine's designed for versatility, whether it's a tractor or pusher installation. The valves? They're manufactured specifically for the Jabiru engine, made of tough materials, and the valve train is lubricated from the oil gallery. And don't worry about valve clearance adjustments. These engines use hydraulic lifters, taking care of that automatically. The cooling system here is pretty innovative. No need for traditional baffles and plenum chambers. Instead, there are specially designed ram air cooling ducts directing air from the propeller to cool the critical parts of the engine, like the cylinder heads. It's a cleaner setup that makes maintenance and inspections much easier. Let's move to the Jabiru 2200 aircraft engine, a lightweight yet powerful four-cylinder, four-stroke engine. At just 132 pounds installed weight, it's one of the lightest in its class and perfect for various aircraft setups. Now, the Jabiru 3300 engine is a beast with its 6 cylinders, delivering around 120 horsepower. It's got a bunch of cool features like overhead valves, a direct propeller drive, and a built-in AC generator. This engine is a champ for a variety of aircraft applications. So, in a nutshell, these engines are not just powerful, but also packed with innovative design elements and features that make them reliable and easy to maintain for all sorts of aircraft.